In this video we'll discuss about modulus of z. So we have here modulus of z. So if we have z defined as this, z is equals to x plus iy, then modulus of z is defined as is represented as denoted as mod of z. This we say mod of z. Okay, and mod of z is equals to under root of x square plus y square. This x is the real part of z and y is the imaginary part of z. Okay. Now if we want to represent it in xy plane, so just consider this y axis is imaginary axis and x is real axis. Okay, real axis. Then this mod z will represent the distance of this point xy from the origin. So you can see the distance will be equals to, using Pythagoras theorem, we can see that this will be equals to under root x square plus y square. Okay, so there are some properties also. So these properties are important properties. Some basic properties are also there, but we are not discussing those properties. Like we are only discussing the properties that are important here, or that are little bit special about mod. So if you have z1 into z2, mod of z1 into z2, that will be equals to mod of z1 into mod of z2. The second one is that is a generalization of the first property, z raised to power n, mod of z raised to power n is equals to mod of z raised to power n. And the third one is mod of z is equals to mod of negative z is equals to mod of z bar is equals to mod of negative conjugate of z, or negative of z bar. So this negative, and you can see this negative, as we are concerned about the square of the real and imaginary term. Here you can see x square and y square. So negative will automatically get converted into positive thing. That is why all these terms are equal to each other. Okay, the fourth property is similar. If we have a mod of z1 divided by z2 bar, that will be equals to mod of z1 bar divided by mod of z2 bar, provided z2 is not equals to 0. This is very important property here. Okay, you should always remember this, because this is going to be used in many of the things, like if you will do the numericals also in or if we will do some proofs in later chapters, this property will be used in many theorems and proofs. So look, mod of z1 minus mod of z2 will be less than equals to z1 mod of z1 plus minus mod of z2, and will be less than equals to mod of z1 plus mod of z2. So here basically this you can see that is coming from triangular inequality. Okay. And other will prove this in the later videos. Okay, upcoming videos will show this thing. Okay, the proof is required. Till now we have seen all these properties, and if let's do one thing. I want you to prove this sixth property by yourself and post the picture, or if you can use a simplified language, you can post that thing in comments. I'll see and I'll check whether it is right or not. Okay, so this is it for this video. Okay, in the next video we'll see some properties and arguments. Okay, thanks for watching.